Question 7 part A, verify the identity, this one, that it is equal to this. So of course, everything in the first bracket here must multiply with everything in the second bracket. So 2x minus 1, then times 4x squared plus 2x minus 1. This one, we shall have 2x multiplying with the 4x squared plus 2x minus 1. Then also minus 1 has to multiply with the 4x squared plus 2x minus 1. So meaning when we try to open the brackets here, we shall have 8x cubed, then plus 4x squared minus 2x. And then when we open here, we shall have minus 4x squared, then minus 2x, then a negative times a negative, that's a positive. So we shall have positive 1 here. And then we shall have 8x cubed. This is 4x squared. This is minus 4x squared. That means this one will go. So we shall have then minus 2x, that is minus 4 of x, and then plus the 1 here. So it is already out. Okay. Then part B, prove this identity here. So I can begin with the left side or the right side to prove the other. Okay. So let me begin with the left side. Tan squared theta minus 1 here. Since this one is in terms of cosine, that means I can write this tan squared plus tan squared theta as sine squared theta over the cosine squared of theta, then plus this one here will be 1. Then we divide by, again, sine squared of theta over the cosine squared of theta minus 1. And then we find the LCM here. This one is over 1. So we just say this times this, then we add on this. Okay. So that means we shall have sine squared of theta, then plus the cos squared of theta, then divide by the cosine squared of theta. Then we divide by what is here is also the same as what we have gotten, sine squared of theta, but then here we shall have a minus. Then we divide by the cosine squared of theta. Of course, this one will somersault, then that means that this one will cancel with that, and we remain with sine squared theta plus cos squared theta is a 1. Okay, then we divide by sine squared theta minus cos squared theta using the Pythagorean identity, this one here. Okay, so that means that in terms of cosine, sine squared theta is going to be 1, then minus cos squared theta. Okay, then there is also this cos squared theta, and then the answer becomes 1 over 1 minus 2 cos squared theta. And that's exactly what they have told us to prove here. So that is that. Then part C, using the results in A and B, solve this equation here. Okay, now this one we have seen it is 1 out of 1 minus 2 cos squared of theta, which is equal to 4 cos of theta. When we cross multiply, we shall get 1, which is equal to 4 cos of theta. And then this one also times this, we shall get 8, right? So minus 8, then cos cubed of theta. If I bring everything this side, we shall get 8 cos cubed of theta minus 4 cos of theta plus 1, which is equal to 0. Now, if we compare with what we got here, okay, compare with this one here, you see 8x squared minus 4x plus 1, which is equal to this one here. So this is 2x minus 1, then into we have 4x squared plus 2x minus 1, 4x squared plus 2x minus 1, which is equal to 8x cubed minus 4x then plus 1. This simply implies that 8 cos cubed of theta minus 4 cos Let me just simplify it this way. This simply implies that x is equal to the cosine of what? Theta. So this one here is the same as this, so I'm going to factorize it this way. So we shall now have 2, then cosine of theta minus 1, and then 4 cos squared of theta plus 2 cos of theta, then minus 1. Okay? Then this one here will be equal to 0. You see that? Then from there, what else do? We have to equate these factors to 0. So equating this one to 0, we shall have 2 cosine of theta minus 1 is equal to 0. That means that cosine of theta is equal to a half, and therefore theta will be the arc cos of a half, which can give us 60 degrees. Okay, so that one is in the first quadrant. Then the fourth quadrant, that is where we are having cosine as positive, but the domain here is from 0 to 180. So when I get the angle in the fourth quadrant, it will be way beyond 180. So I'm just going to choose this one here. Okay, then this one here, I'm going to solve it. It's a quadratic equation and it is not factorizable. So I can use the bulldozer method or the quadratic formula, where x is equal to minus b. Remember, this is a quadratic in cos of theta. So cos theta is going to be equal to minus b, then plus or minus to the root of b squared minus 4ac. Okay, then out of 2a. Then cosine of theta here is going to be, first of all, this will be a positive 16, then plus 4, that will be a positive 20. So root of 20 is the same as root of 4 times root of 5, and then this one will give us 2 root of 5. So I'll write minus 2 plus or minus 2 root of 5. By the way, down here we have 2 times a, which a is a what? A 4. Okay, then out of 8. Now, cosine of theta will be equal to minus 2, then minus 2 root of 5 over 8. And also cosine of theta can be equal to minus 2, then plus 2 root of 5 over 8. Okay, now from here, what will be our theta? Our theta, of course, is going to be the arc cos of this negative 2 minus 2 root of 5, then out of 8. Also here, theta will be the arc cos of negative 2 plus 2 root of 5 over 8. Okay, this is a trigonometric function, so you have to make sure that your calculator is in degrees. Okay, so if we put negative 2, then plus 2 root of 5, then down here we have 8. Okay, this one is a positive value. Okay, that means we are going to get the angles in the first quadrant and in the fourth quadrant, but we only need angles in the fourth quadrant. First quadrant. So I would say arc cos of this one will give us 72. It is exact. So this one is 72 degrees. Then how about this one here? First of all, this one is negative. When I put a negative here, this whole thing is a negative, and cos is negative in the second quadrant, right? And third quadrant. So if I just say arc cos of this, the calculator will give me that obtuse angle in the second quadrant straight away, which is 144 degrees. Then I will conclude and say theta is going to be equal to 60 degrees, then 72 degrees, and then 144 degrees. As simple as that.